Hi children, today let's study a new topic, curves and polygons. Curves and polygons. After this module, you can understand about curves and polygons. Okay, let's see some figures here. You can see these figures have no definite shape or size. This we drew just with a pencil, no correct measurements. These type of figures are called curves. These has no definite shape, size or measurements. Okay, the pictures that are results of your doodling are called curves. Doodling means we just draw without any measurements, without any instrument, rulers, compass, no, etc. We cannot use this much for drawing curves. Okay, see these curves. These curves, any speciality here? These curves cross itself. We can see here the one side is overlapped to another. That is, these three curves cross itself. The second figure is only with line segments. The other two are doodling. Okay, these curves cross themselves. Next, we can see another figures here. 5 curves are here. These 5 curves do not cross. Do not cross. They touches each other for closing its shape, but they cross each other. Listen, these figures, they cross itself, but these 5 curves do not cross. These curves do not cross itself, then it is called simple curve. It is called simple curve. Next, you can see 2 curves here. Any specialties here? Yes. First figure is not closed. Second curve is closed. So, very simply we can identify first curve as open curve. The name of the first curve is open curve. Then very simple, the name of the second curve is closed curve. Open curve and closed curve. Next, here we can see a curve. A closed curve is there. 3 points are there. Point A inside the curve, point C outside the curve, and point B is not inside, not outside. Point B is, that means the dot. Point means the dot. Dot is on the line of the curve. So, some names here. Where is point A? Inside the curve. So, point A is in the interior of the curve. Interior means inside. Point A is in the interior of the curve. Then point B is on the curve, on the line of the curve. So the name is point B is boundary of the curve. Boundary, that is the boundary. That line is the boundary of the curve. So point B is on that boundary. Point B is boundary or on the curve. 2 names are there, boundary or on. Boundary of the curve. Then very clearly we know point C is outside the curve. So what's the name? Point C is exterior of the curve. Exterior means outside. Exterior of the curve. Interior, inside. Exterior, outside. Then on the curve means boundary of the curve. Okay, next one question is here. Classify the following curves as open or closed. Very simply we can identify a curve is open or closed. First figure, which type of curve is that? open or closed? Very clearly we know it is open curve. Open curve. Second figure is not open. So its name is closed curve. Closed curve. Third figure we know it is open, not touch each other. So open curve. Fourth one is closed curve. Okay, next we have to study polygons. Have you heard this word polygon? Look these figures. Four pictures are there. Very clearly we can see these four pictures are made up of line segments. Made up of line segments. In the first figure there are 5 line segments. Second figure 3 line segments, and in the third figure how many line segments you count and find, and the fourth also. So polygons means the figures with line segments only. We don't use curve. We don't draw by doodling. Okay. So these are made up of line segments only. They are called polygons. Polygons are the closed figures with line segments only. Only line segments we can use to draw a polygon. It is closed also, not open. It is always closed. Here you can see a polygon. How many sides for this polygon? 5 sides for this polygon. How many points marked on this polygon? 5 points. Okay. Now we study about this 5-sided polygon. We know how many sides here? 5 sides. So we have to name these 5 sides. First side is starting from A. Line segment AB. Okay. AB is a side of this polygon. So we write here line segment AB. Next, BC is another side, second side BC. So BC is second side. We have to write line segment BC just like we write all the 5 sides. Next, starting from C, CD is a line segment. CD is a side. So write line segment CD. Next, DE. Okay, DE is the fourth side. DE is the fourth side. Line segment DE. Next, the fifth line segment. Fifth side is EA. Is the fifth side. So we have to write it as line segment EA. These are the 5 sides of this figure. Next, we have to see here 5 points. This shape has 5 points. That means this shape has 5 meeting points. Listen very carefully to the screen. Consider line segment EA. That is side EA and AB. EA and AB. Then side EA and BA, starting from B, side EA and BA meets at the point A. That is side EA and side BA meet at A, point A. So A is called vertex. A is called vertex. Then just like side AB and side CB and AB meets at a common point B, intersect at B. So B is called vertex. So A is vertex, B is vertex, just like C, D, E are vertex. So vertex is used for only single point. The plural form of vertex is vertices. Vertices. You can see here. The meeting point of a pair of sides is called vertex. Vertex is used for a single point. Then plural is vertices. So how many vertices here? Point A, then point B, point C, point D, point E. 5 vertices for this figure. 5 vertices. Remember, vertex is used for only a single point. If there are 2 points, we have to call it as vertices. Next, the part is diagonals. Diagonals, we know the line segment joining opposite vertices, opposite points. Here, starting from A, if we draw a line segment opposite to A, which is the opposite point of A? B is opposite, but AB is already a line segment there. AB is already a side of this figure. So we cannot use AB. We can use AC. AC is opposite. Point A and point C are opposite. So we can draw a line segment joining A and C. Therefore, line segment AC is a diagonal. Line segment AC is a diagonal, just like line segment AD joining A and D. AD is second diagonal starting from A. Then balance is AE. AE is already a side of that polygon, so we cannot use AE. Just opposite points, opposite vertices. Then join a line. AC and AD are diagonal. Then we go to point B, vertex B. Then starting from B, which is the diagonal? BE is the diagonal. BE is the diagonal. Then another one, line segment BE, we can see as diagonal. Another one, line segment BD. BD is the fourth diagonal. BD is the fourth diagonal. Then go to our C, point C, which is the diagonal from C. We can draw CA, we can draw. Already we drawn CA. Then CE, we can draw CE. Okay, CE, line segment CE we can draw. Then any other? No. Then move to D. Starting from D, DB. DB already here. DA already here. Just like E. Starting from E, EC diagonal, EB diagonal. So, from each vertex there are 2 diagonals. So, total 5 diagonals for this figure. Some diagonals we already drawn. So, only 5 diagonals for this figure. That is 5 points here, 5 diagonals also here. Okay, that's all for today. Thank you.